Let's be completely honest for a second. We've absolutely all been there. You're finally wrapping up a grueling semester of research, you're totally exhausted, and you just save your giant spreadsheet as data_final_v2.csv. You dump it into a random folder and you promise yourself, hey, I'll organize this later. But will you? Honestly, are you going to remember what those vague column headers actually mean in 5 years, or let's be real, even in 5 months? For most of us, the terrifying answer is a hard no. And unmanaged data? Well, that's just a massive nightmare waiting to happen.
So, welcome to this explainer. Today, we're taking what most people think of as a pretty tedious administrative chore and transforming it into a literal project-saving superpower. We're drawing directly from some fantastic microguides developed by Dr. Fadwa Al-Shawaf to arm you with the ultimate young researcher's survival guide to data management. Whether you're a student just getting your feet wet or a researcher trying to finally streamline your workflow, getting familiar with research data management is absolutely going to elevate your work from good to great. Here's our quick roadmap for today. 1. What is research data management? 2. Creating your data management plan. 3. Documentation and metadata basics. 4. Quality control and data storage. And finally, 5. Team roles and responsibilities. All right, let's jump right in.
Section 1. What exactly is research data management, or RDM? And how do we shift our mindset from seeing it as a total chore to recognizing it as a superpower?
You see, research data management isn't just scrambling to find a place to save your files at the very end of a project. It's a highly structured approach that spans your project's entire life cycle. It's actually a continuous loop. You start with planning, then you move on to collecting and documenting. Next comes processing and analyzing all that data, followed by publishing your findings. But hey, it doesn't stop there. The cycle continues right into long-term archiving, which ultimately allows for the reuse of that data, either by future you or by entirely different researchers. RDM just ensures that at every single one of these 6 steps, your data remains perfectly understandable, secure, and compliant. So, the million-dollar question: why should you actually care? Well, beyond just keeping your desktop from looking like a disaster zone, good RDM directly boosts the quality and the impact of your research. Transparency means other people can actually verify and reproduce your work. Impact and visibility, that means well-managed, shared data significantly increases the reach of your research. It makes collaboration across the whole scientific community so much easier. And frankly, it saves you from reinventing the wheel on your future projects. Plus, let's not forget the big one: compliance. A lot of funders and institutions literally require structured data management now. Okay, time for a reality check. On the left here, we see the classic traps we all fall into: treating documentation as a total afterthought, relying on completely random ad hoc file names, or just assuming you'll remember later how the data was created. Spoiler alert, you won't. The golden rule, right there on the right, is to think about RDM as early as humanly possible. Ideally, when you're just planning the project, way before you collect a single piece of data. Planning early prevents data loss, massive confusion, and those rushed, panicked decisions down the line.
Which brings us perfectly to Section 2, creating your data management plan. You can think of this as the absolute blueprint for your success.
So, what exactly is a data management plan, or a DMP? Technically, it's a planning document that explicitly lays out how your data will be handled from the very moment of creation all the way to long-term preservation and sharing. But here's the real takeaway. A DMP is a living document. It is absolutely not something you just write once to satisfy some grant funder and then shove into a digital drawer forever. It evolves as your project evolves. It drastically reduces your risks and saves you an unbelievable amount of time later. And like we mentioned, it's usually required right at the proposal stage anyway. So how do we make this actionable? Well, your DMP essentially forces you to reflect on a few core elements. You really have to think through data description, like what exactly are you even creating? You've got to consider documentation, data storage, legal obligations, data exchange, and of course, responsibilities. Listen, if your project involves personal or sensitive data, or even just really large, complex data sets, having these elements clearly defined in your DMP isn't just a nice to have, it's absolutely vital for your project's survival.
All right, we have our blueprint. Now, Section 3, let's talk about the day-to-day language of data, documentation and metadata basics. I really want you to burn this quote into your memory. Undocumented data are effectively lost data. It is a harsh truth, but without proper documentation, data simply cannot be reliably found, interpreted, or reused. Not by your colleagues, not by the scientific community, and certainly not by future you.
Documentation includes things like your README files, context, and variable definitions. It provides the absolutely crucial context that actually brings raw numbers to life.
And a massive chunk of that documentation is metadata. Metadata is essentially structured information for discoverability and interoperability. It's basically the data about your data. To make sure everything works smoothly together, you should really stick to a simple, highly effective metadata checklist. You need a clear dataset title, creator names with identifiers like your ORCID, a really rich description of the data, standardized keywords or subject terms, and obviously your licensing info. Oh, and here's a huge pro tip directly from our source material. Do not leave this as a rushed final step. Seriously, just keep a metadata text file updated continuously during the project. It saves you massive headaches later and dramatically improves the quality of your final upload.
Moving right along to Section 4, we've got our well-documented data, but now we need to make sure it's secure and high quality. Let's look at quality control and data storage. Okay, so while good metadata makes your data discoverable, good data quality is what actually makes it trustworthy. But what does quality even mean in the real world? Well, it rests on 4 key pillars. First, it must be accurate, meaning the values actually correctly represent what you measured. Second, it must be complete, with absolutely 0 undocumented gaps. Third, consistent, using uniform formats, units, and codes across the board. And finally, reliable, meaning it can be clearly understood and used far beyond your original project. High data quality is literally what allows the scientific community to trust your results.
But look, all that amazing quality means absolutely nothing if you just lose the file. When we talk about short-term data storage while you're actively working on your project, we are constantly balancing accessibility with strict data protection and legal compliance. The guides we're looking at strongly urge researchers to stop relying on personal devices. Seriously, no more saving primary data exclusively to your laptop or random USB sticks. Instead, use your institutional storage services. Why? Because they automatically provide the good stuff: redundancy, automatic backups, and really secure access control. Organize your data into clearly named project folders, set the right access permissions, especially if you've got sensitive data, and secure your foundation so your hard work is physically safe.
Now, if all of this is starting to sound like a ton of responsibility for just one person, take a deep breath. Section 5 is here to remind you, you are not alone. Managing research data is absolutely a team sport, and it operates within a distinct ecosystem. Look at it this way. As a researcher, your day-to-day job is to collect, document, and organize the data following the practices you all agreed on. But your principal investigator, the PI, they hold the overall responsibility. They're the ones ensuring all the legal, ethical, and funder requirements are met. And they approve the final decisions on data sharing. And backing both of you up, that's institutional services. They provide the heavy lifting, the infrastructure, the servers, the automatic backups, and the long-term repositories. Every single one of you has a vital part to play in making sure this data actually survives. Which brings us right to our final question. Are you ready to make your data outlive your project? By planning early, documenting thoroughly, locking in that quality, and actually utilizing your team, you're no longer just doing some boring administrative chore. You are stepping up as a responsible steward of your entire field's knowledge. You're ensuring that the grueling hard work you're putting in today is going to continue driving scientific discovery for generations to come. So take these tools, go build your data management plan, and turn your raw data into a lasting legacy. Thanks so much for joining me on this explainer, and hey, happy researching!